Hello. The purpose of this particular video is to discuss the nomenclature of acids. If you have not already done so, previous to viewing this video, please view the videos on the nomenclature of binary ionic compounds and the nomenclature of ionic compounds containing polyatomic ions. The information presented in those videos is utilized in the nomenclature of acids. Before we can write the name or formula of an acid, we must understand what our definition of an acid is. For our purposes, acids are any aqueous compound that has a formula that begins with an H+. So if you see an aqueous compound whose formula begins with an H, we will assume that that is an acid. Naming acids depends solely on the name of the anion or negative ion present in the acid, since all acids have H+. Writing the formula of an acid requires us to keep a few things in mind. Number one, the name of the acid will tell us the formula of the anion present in the acid. Assuming we know the formula of that anion, we can then add the appropriate number of H+ ions so that the total charge on the acid equals 0. This is probably best illustrated by a few examples. There are really three scenarios or three different types of anions that we are aware of. We'll start at the top and work our way down. The first anion is an anion that ends in IDE, meaning an anion that does not contain any oxygen, such as chloride, Cl1-. To turn chloride into an acid, if you add H+ to it, you get HCl. If we want to name HCl, the first thing that we will do is insert in front of the word chloride the prefix hydro. We will then change the IDE in chloride to IC, giving us hydrochloric, and then add the word acid. So HCl contains the Cl1- anion and is named hydrochloric acid. Now, if it's not aqueous HCl, it is named as a molecular compound. So if it is HCl gas, it is named differently. Molecular compounds will be discussed in a separate video. If the anion's name ends in ATE, then naming the acid is slightly different. Let's look at a couple examples. Let's assume the anion present in our acid is ClO3 1-. That is the chlorate anion. The name of our acid is formed by dropping the ATE from the anion name and changing it to IC, and then adding the word acid. So HClO3 is chloric acid. Chloric acid. In a similar fashion, if the anion present in our acid is ClO4 1-, such as the acid HClO4, then ClO4 1- is perchlorate, which means the acid HClO4 is perchloric acid. The final scenario is if the anion present in our acid ends in ITE. For example, an acid with the formula HClO2. ClO2 1- is chlorite. When we name an acid that contains an anion whose name ends in ITE, we change the ITE to OUS. So HClO2 is chlorous acid. Similarly, if our acid is HClO, ClO 1 minus is hypochlorite, we get hypochlorous acid. As you can see, if you do not know how to recognize the formula of the anion in the acid, and you do not know the name of the anion in the acid, it is impossible to name an acid. And it will be very difficult to go from its name to its formula. Let's see if we're on the same page. We want to know which of the following is the correct name for H2SO4 aqueous. Pause the video now, select your answer, and then hit play to see an explanation. H2SO4 contains the anion SO4 2-, which does contain oxygen, which means there will be no hydro prefix in our name. SO4 2- is sulfate. The name of the acid is sulfuric acid. I put this example in because acids that contain sulfur, instead of being sulfic acid, which would follow the rules I just presented, present a little bit of a challenge. For whatever reason, unbeknownst to me, the root word, instead of using the root of the anion name sulf, it returns to sulfur, and then you add the IC. You'll get more comfortable with these as you practice more. Let's look at one more example. Which of the following is the proper chemical formula for phosphoric acid? Pause the video, select your answer, and then hit play for an explanation. Phosphoric indicates phosphate, which is PO4 3-. We know it's PO4 3- because there was no hydro prefix, which means it's phosphate. And because it's PO4 3-, to make it a compound with 0 charge, we need 3 H pluses, which means it is H3PO4 aqueous is the formula of phosphoric acid. The keys to writing the names and formulas for acids lie in identifying the appropriate anion present in that acid. So it is key in naming acids and writing their formulas that you have a good working knowledge of the negative or anions that are possible, both ones that are polyatomic ions and ones that are monoatomic, whose charges and things we can predict from the periodic table.